Okay, so welcome everybody to Medicine in the Moment. My name is Otis, and I'm an undergraduate biomedical engineering student at Johns Hopkins University. And this channel was kind of born out of some of the experiences I've had working with health-related data at Hopkins. Specifically, the amazingly powerful ways in which you can leverage that data to solve some of the what I think are the most pressing problems in healthcare. And this first video will be discussing exactly that. Why is big data important in healthcare? And in what ways might healthcare professionals be able to use it to solve problems in their field? Before we start, I would like to give a disclaimer that this is by no means a purely data science focused channel. My goal with this channel is rather to explain data science concepts while always applying them to clinical situations, so it can help you and other viewers remember the real world significance of the topics we'll be discussing. One of my favorite quotes that I think describes this well actually is the following. In theory, there is no difference between theory and practice. In practice, there is. Can you guess who it's by? It's not actually by a data scientist or physician. It's by Yogi Berra, the late baseball catcher. And I think in this situation, Mr. Berra has very eloquently summed up what I'm trying to say. So with that, let's get into it. As I'm sure many of you already know, right now there is just massive growth in the amount of healthcare data that is generated each year. Just for a comparison of magnitudes, in 2013, there were 153 exabytes of medical data, or 153 billion gigabytes. 7 years later, in 2020, we had 2,314 exabytes, which was around 15 times the amount of data there was in 2013. Worldwide data capacity for health in 2020 was only around 985 exabytes, meaning that almost 2.5 times more storage would be needed to store all the medical data generated, as this histogram illustrates. So evidently we're in a bit of a confounding situation. How do we increase this data capacity? Or, more importantly, are there ways that we can optimize this massive amount of data being generated so that it can fit into the data stores we currently have? What we call this mass of structured and unstructured data is big data. In healthcare, big data can derive from sources like electronic health records, patient surveys, and many others. There are, though, a few aspects of big data that we have to leverage in order for it to be meaningful for us. The first is volume, which is the sheer size of the data. So linking back to what I mentioned on the previous slide about optimizing data, what we're really talking about is managing the volume more effectively. This can be done through, for example, artificial intelligence, which allows healthcare providers to parse through data and perform data analysis tasks more rapidly. The next is veracity, which involves establishing accuracy and, as a result, trust in big data in healthcare. There's a lot of hesitation among healthcare professionals around the idea of big data, and reasonably so, because of concerns about patient confidentiality, potentially dangerous errors, among other things. But by working on data assurance and guaranteeing that data analytics are error-free, we can progress towards this widespread integration of big data in healthcare. Then we have velocity, which is not the physics concept, thankfully, but the idea is kind of the same. One of the major issues with data analytics in healthcare right now is that it takes time for that analysis to happen, for extraction to occur from these large data sets. You can think of it as trying to find a book or two in a huge library. This has, of course, been improved over time with advances in computing power. But the healthcare industry is extremely time sensitive, so we still need to work on extrapolating insights as data is streamed in, streamlining or even almost eliminating that search process. Finally, there's variety, which is of course inherent in big data because it comes from so many different sources. For this aspect of big data in healthcare, we need to work on analyzing different types together and at the same time. Research has shown that combining, for example, data from different physiological parameters has led to more accurate detection of conditions like elevated intracranial pressure. The human body is a highly interconnected system, so we really need to reflect that in our analysis of data that comes from it. So you might be wondering, what are some of the bigger benefits of all this effort with big data? Well, with connected data and artificial intelligence, we can get closer to resolving some of the biggest problems in healthcare, such as chronic disease, uncertain prognoses, and high-cost acute events. Researchers at Intermountain Healthcare in Utah, for example, recently applied AI to organize and prioritize patients in early stages of chronic kidney disease, with the goal of reducing hospitalizations. They were able to accurately identify CKD patients based on presence and stage of acute kidney injury, and categorize them based on gaps in care and time since their last visit. In another case, a team at Stanford's Human-Centered Artificial Intelligence Center found that quantitative analysis of COVID patients' CT scans was able to predict with greater accuracy whether they would stay in intensive care, require the use of a mechanical ventilator, or pass away. Clearly, there's great potential for AI to have a significant impact on our healthcare systems and the health of the public. And in fact, this health revolution has already started, and it's happening all around us all the time. Just look at the numbers. In 2016, the value of the life sciences analytics market was $13 billion. In just 5 years, with a compound annual growth rate of 13.3%, that value has grown to $25 billion, an almost twofold increase. If you look at the graph on the bottom, it shows what is called an analytics maturity curve. Essentially, it shows the progression of sophistication in our data analysis capabilities, with complexity on the x-axis and customer value on the y-axis. Most healthcare and life science institutions today are situated on the lower end of the curve, with descriptive and diagnostic analysis capabilities only. However, we want to move to the upper end of the curve, where we're no longer just capable of describing the past and the present, but the future as well. We want to be able to identify what will probably happen under a certain set of circumstances and what we should do to achieve the best possible outcome. So what can we do to move along the curve? Well, there are a few things. The first is extracting meaning from data and turning it into something that's interpretable, which can be communicated to all relevant parties, patients included. This way, patients can take more responsibility and make better healthcare decisions, being not only engaged, but also taking action on their own behalf. This is very similar to the next point, which is moving from a more product-focused to service-focused approach. We also want to create predictive health intelligence, which is essentially the process of integrating a patient's real-time and historic health data to predict their health outcomes. Finally, we want to democratize data access throughout institutions so that every accredited individual within the institution can access data. We can deploy tools to even allow people with limited data analysis skills to understand data simply and use it to make their own decisions. Okay, so that brings us to the end of the very first video of Medicine in the Moment. Next video, we'll be getting more into the details of artificial intelligence, a topic I mentioned briefly in this video, but that may still seem kind of mysterious to you. I'll be discussing the different branches of artificial intelligence and some of the big ideas that are central to it. So I hope you enjoyed this video, and I'll see you in the next one.